Hi guys, welcome back to YouTube channel Foundation Chemistry AB. So let's discuss today the quantum numbers. So this will be highly beneficial for class 11th and 12 students. So I have a simple message for you guys. Please think for innovation, be creative, learn everywhere, anytime and help to learn others. So let's talk about what are quantum numbers and their significance. So we know there is a wave equation that is called Schrodinger wave equation. So if we solve the Schrodinger wave equation, we get the wave function that is psi, or we can call it orbital. And when we take the square, so that we get square psi square. So that is the probability of finding an electron in a region of space. So the behavior of an electron in an atom is described mathematically by a wave function psi, or you can say orbital. And each wave function contains three variables called quantum numbers. N that is the principal quantum number, L that is the azimuthal quantum number, and M is the magnetic quantum number. So let's define what are quantum numbers. So the quantum numbers are identification numbers for an individual electron in an atom, since it can describe fully the position and energy, define shape and orientation of the region in space where the electron can be found. So there are four types of quantum numbers. So let's discuss one by one. N that is the principal quantum number. So N denotes the energy level or principal cell to which an electron belongs. So N value varies like a positive integer 1, 2, 3, 4 like that. So when N equal to 1, we have the cell that is the K cell. When N equal to 2, that is L cell. N equal to 3, that is M cell, and when N equal to 4, that is N cell. So this is the concept of cell. So N gives idea about size of the cell and is the same integral of as suggested by Bohr MVR equal to NH upon 2 pi. The next is L, the angular momentum quantum number. So L gives a shape of the orbital. So L can have values from 0 to n minus 1 number of values. So when n equal to 1, so n minus 1 that is 1 minus 1 that is L equal to 0. So that represents 1s orbital. So these are called subcells. So when n equal to 2, so L can have a 2 minus 1 that is 1 and then 1 minus 1 that is 0. So L can have 0 and 1. So L equal to 0 that is 2s orbital. When L equal to 1 that is 2p orbital. So these are the subcells. So when n equal to 3, L can have values 0, 1 and 2. So that means starting from 0 to n minus 1 values. So when L equal to 0 that is 3s orbital. When L equal to 1 that is 3p orbital. When n equal to 2 that is 3d orbital. So when L equal to 0 that is represents s orbital, L equal to 1 that is p orbital, when L equal to 2 that is d orbital, when L equal to 3 that is f orbital. So this S stands for sharp, P for principal, D for diffused and F for fundamental. So these SPDF orbitals are subcells. So let's talk about the next quantum number, magnetic quantum number M. So M defines orientation of orbital in space. So M have values starting from minus L to plus L. So when n equal to 2, L can have values we know that is 0, 1 and M can have value. When L equal to 0, M will have 0 value. And when L equal to 1, M can have a minus 1, 0 and plus 1. So M equal to 0 means 2s orbital and M minus 1, 0 plus 1 that is 2p orbital. So that's why we have three 2p orbitals, 2px, 2py and 2pz. So the total number of values of M that is equal to 2l plus 1 values. So when L equal to 0, M equal to 1 value and M equal to 0. So when L equal to 1 that is p orbital and we can have M equal to 3 that is minus 1, 0 plus 1. When L equal to 2 that is d orbital. So M can have 5 values minus 2, minus 1, plus 0, plus 1, plus 2. So dxy, dyz, dzx, dx square minus y square and dz square orbital. And here you have px, py and pz. So the total values of M for a given value of L gives the total number of space orientations of S, P, D and F orbitals. So let's talk about the spin quantum number, that is S. The electron, while moving around the nucleus in an orbit, also spins or rotates about its own axis either in clockwise or anti-clockwise direction. So S can have plus half, or you can have anti-clockwise direction minus half value. So here we can see in the table, so N is the main cell, that is N equal to 1, that is K cell, and here on the orbital, so when L equal to 0, that is 1s orbital, and M the orbital orientation, so it can have values minus L to plus L. So M equal to 0, that is 1s orbital, and the spin value can have plus half or minus half. So the total number of electron, that will be 2 into 2L plus 1, that is 2. And total number of electron in the main cell will be 2n square. So 2 into 1 square, that is 2. So when n equal to 2, that is L cell. So L value can have L equal to 0 and L can have 1. So when L equal to 0, that is 2s orbital. When L equal to 1, that is 2p orbital. And when M equal to 0, that is 2s orbital. And spin quantum number can have plus half and minus half values. And when M equal to 0, that is 2px orbital, M equal to plus 1, that is 2py orbital, and M equal to minus 1, 2pz orbital. And in each case, the spin quantum number can have for electron 1 plus half value and for electron number 2 minus half. So as a result, you can have 2 plus 6. So total number of electron in the main cell will be 8. Similarly, you can explain for n equal to 3, you can have L value 0, 1, 2 and M values can have a total 18 number of electrons. So let's try some problem. So give the allowable combinations of quantum numbers for each of the following electron: 4s, 3p electron, 5f and 5d electron. So for a 4s electron, so n equal to 4, L equal to 0 and ml equal to L equal to 0 means M equal to 0, so ms will be plus minus half. For 3p orbital, n equal to 3, principal quantum number, and L value will be equal to 1, azimuthal quantum number for p orbital, and L equal to 1, so magnetic quantum number M equal to plus half, plus 1, 0, minus 1, and spin quantum number will be plus minus half. Similarly for 5f orbital, so n principal quantum number is 5, for f orbital L equal to 3, so magnetic quantum number M will be plus minus 3, plus minus 2, plus minus 1, 0. So you have 7 values, and ms value will be plus minus half. So let's try another problem. Give orbital notations for the electrons in orbital with the following quantum numbers: when n equal to 2, L equal to 1 and M equal to 1. So these are the problems for you guys, you try on your own. Similarly, give the allowed combinations of quantum numbers for the following orbital: for 3s orbital, 2p orbital and 4d orbital. So please subscribe to our channel Foundation Chemistry AB. So this is also available in the website www.foundationchemistryab.com. So for class UG/PG, this is the channel Chemistry Live UG/PG. So this is a simple step towards e-learning, making life better. Thank you all for learning.